What's up, guys? Mr. Jones here, and today we are talking about properties. No, we're not talking about monopoly properties, but what we are talking about are properties of equality. Not as fun, but maybe more important. Now, what is a property? A property is kind of a rule that makes it possible for us to solve equations the way that we do. So we have a whole bunch of them, right? Because there's a whole bunch of different things that we use in order to solve an equation, but it's these rules, these properties that make that possible, okay? So I'm just going to go through a bunch of them. Some of them you're probably familiar with and you may have heard of before, and some of them may be brand new. Okay, so the first one you've probably heard of already at this point, the distributive property. Okay, so I'm just going to give the general definition, kind of displaying it just using letters, which might be confusing, but it shouldn't be because I'll give an example and that should solidify it. Right, the distributive property says if you just have something multiplied by a group of terms, or that's called a polynomial. But when we multiply, right, we would say A times B, and then the outside thing times the second term as well. So that's basically what the distributive property says, is that when we have something multiplied by a group, we multiply that thing by everything in the group. So like if I had -4 times 2x minus 7, right? This is a single term multiplied by a group, okay? So I multiply both of these by the -4, right? And again, we've done this before, so I don't need to show every step, but yeah, right, -4 times 2x is -8x, and the -4 times, again, we think of this as -7, -4 times -7, positive 28. Now the commutative property, the second one, okay, it's really easy to mix these up. Common mix-ups, right? So it's really easy to mix these up because all of these involve similar types of things. So the commutative property and the associative property especially, it's really easy to mix these up. So I'm going to give you a fun way to remember, especially the associative property. Anyway, so commutative property, what does that say? Well, that says that, so if we have like A plus B plus C, so if we're just adding three things together, it doesn't matter what they are, we can change the order of how we add them. Like let's say B plus C plus A. Right, we can kind of change the order of how we add them, but it'll still result in the same answer, okay? So like a real life example of that would be if I did like 1 plus 2 plus 3, and we know that 1 plus 2 plus 3 is 6. But if I did another order, so if I did like 2 plus 1 plus 3, that would also equal 6, right? Even though we're doing it in a different order, it doesn't matter, it results in the same answer. But it doesn't just work for addition, okay? It also works for multiplication, okay? So separately, if I had A, B, C, or that's saying A times B times C, that's the same as B times A times C, right? The order when you're multiplying things doesn't matter either. So if I did the same thing, if I had like 2 times 3 times 4, that equals 2 times 3 is 6, 6 times 4 is 24, okay? That would be the same as 4 times 2 times 3, right? So 4 times 2 is 8, 8 times 3 is 24. So you get the same thing no matter the order that you multiply them. But it only works for addition and multiplication. It does not apply to subtraction or division, our other two operations. So that's commutative property. My way of remembering that one is, right, commutative property is where things change or the order changes. You change the order that you add or multiply things. So changes order, commutative, CO, changes order. Okay, that's how I remember commutative property. Okay, associative property is very similar. Okay, but look, associative property is when we have like another list of terms, right? But we have like parentheses kind of denoting to add a certain group first. Okay, so like add these two first and then add this one. It doesn't matter how you group them. Doesn't matter how you group them, is still going to result in the same answer. And that's true for addition and multiplication as well. So same idea, if I had like 2 plus 5 plus 8, that's going to equal the same thing, right? Because 2 plus 5 is 7, 7 plus 8 is 15. Okay, that's going to be the same thing as 2 plus 5 plus 8. If I added the 5 plus 8 first, 5 plus 8 is 13, 13 plus 2 is 15. This is very similar to the commutative property, but it's those parentheses, okay? So notice, and this is very true of the associative property, the order itself doesn't change, right? Because look, 2, 5, 8, 2, 5, 8. The order is the same on both sides, but it's those parentheses that change, okay? And here's my way of remembering it. A college professor told me this, and I never forgot it. Parentheses kind of look like somebody's behind, and the associative property begins with another word for somebody's behind. There's your way of remembering it. I'm sorry that that's a little bit inappropriate, but in terms of a memory trick, it works. So there you go. Moving on. 4, 5, and 6, okay? Especially these two are very easily mixed up as well because their names are similar. They both begin with I. Identity property, also like the other ones, also apply to addition and multiplication, okay? Identity property is kind of what we do to a number without changing its identity, okay? So if I have 4, I'm wondering what can I add to that to keep it as 4, to not change its identity? And that would be 0, right? Adding 0 to something does not change its identity, okay? Separately from that, and I won't give any math examples, I'll just stick with these because we get the idea. Same thing, if I have 4 times something, what can I multiply it by to keep it as 4? And that would be not 0, but 1, right? Anything times 1 equals itself. So you can have the additive identity, which means adding 0 to something doesn't change its identity, and multiplying 1 by something does not change its identity. It keeps it the same. So that's how I remember it, is you don't want to change its identity. All right, inverse property. Inverse property is similar, but we're wondering, right, kind of, again, when you see the word inverse, I almost always think of a similar word, reverse. Reverse and inverse are similar, and that's kind of what we're doing with the inverse property, or what that's showing. Like if you have 4, I'm thinking, okay, if I have 4 of something, I want to kind of do the inverse or opposite of that. And so that would be adding its opposite number. So 4 plus -4 will take you back to 0. So if I give you $4, and then I say, give me $4 back, I did the inverse of what I did initially. I gave you 4, and then I want 4 back. So the inverse property is adding something's opposite. But with multiplication, right, it's like if I had 4 and I wanted to multiply and get its opposite, okay, I wouldn't do 4 times -4 because that would equal -16, and that's not necessarily reversed. But, right, you might have heard this word reciprocal, right? Reciprocal means the flipped version of a number. So, right, if this was 4, or again, we've said that's the same as 4 over 1, the opposite of that would be 1/4. That's its reciprocal, meaning that, and if I do 4 times a fourth, that gives me 1 as an answer, and that's its inverse, or reversing 4 through multiplication, okay? And you might be saying, but I don't end up at 0. And so you notice how there's a relationship between the identity and inverse property, where it's kind of, and that's why it's easily mixed up too, because, right, identity property, you're adding 0 and you're not changing its identity, but inverse, you're getting that number as an answer. And it's same with the multiplication, where you times it by 1 to not change its identity, but you're getting 1 as an answer by multiplying its opposite. Tricky one, and I say that here, tricky one. Transitive property. The transitive property, I see transitive, and the first thing I think of is the word train. Okay, it's like a train of things happening. Okay, and so that's what's going to happen here. Okay, so explaining what transitive property is, I'm going to have 3 statements. Okay, and they're going to be related to each other. Okay, so look, my first statement is A equals B. So I just have one thing, and that equals some second thing. Okay, again, they're unknown, but that's just going to be the definition for now. And then my second statement says, okay, B equals C. So what this is saying is that same second thing from here, that second thing equals a third thing. Okay, so here's how I like to say that to my kids. Okay, a first thing equals a second thing. Okay, and then that same second thing equals a third thing. So the result of that, kind of the logical conclusion we can reach from that, right? If A is equal to B and B is equal to C, then that means that A must equal C, right? Because A and C are both equal to the same thing. And again, equality means that if these two equal the same thing, that means these two must be equal to each other. So the kind of the resulting end statement is that the first thing must be equal to that third thing. Now you might be saying, oh my gosh, that's too much. Okay, let me give you a real example, okay? How we often see that in algebra type problems, okay? And I'll just tell you, almost always when you see the transitive property asked, like a question on a quiz or a test, you'll see it like this, like I'll do. Okay, so I wrote all that out, okay? And I know that seems like a lot. Just, again, try to stay with me and I'll break it down, okay? So 2x plus 3 equals 5y. That's my first statement. Okay, 2x plus 3 equals 5y. And this pattern up here is going to be the same for every transitive property problem. So what I have here, again, there's a variable in there, but just to simplify it a little bit, this is just, you think of that as thing 1. Even though it's a group, that's just thing 1. So my first thing equals some second thing. Okay, so 2x plus 3 equals 5y. First thing equals some second thing. And then we move on to statement 2. Okay, the second statement says 5y. Again, that same second thing equals some third thing, some other unknown thing. So thing 1 equals thing 2 equals thing 3. So that means the resulting statement is so 2x plus 3. And again, you look back, 2x plus 3 is my first unknown thing. So thing 1, 2x plus 3, again, based on my transitive property, it says, so that first thing must equal that third thing. So here, that first thing, 2x plus 3, must equal my third thing, 7z. Okay, so that would be like the answer. So that's the transitive property. Okay, I'll do some more examples of that in the next video. Okay, but a few more, okay, 8, 9, and 10, just a few more of these. Substitution property, okay? So if you have a statement like just, first off, saying like x equals y, so just those two unknown things are equal to each other. But then if you have a statement like, so if x equals y, if these two unknown things are equal to each other, and then if you have like x plus 4 equals 9, okay, that means that you could write, if two things are equal to each other, that you can replace one with the other. That's basically what it means. And you guys know that. But so the substitution property would say that, okay, if we know that x equals y and x plus 4 equals 9, then also y plus 4 equals 9. So you can replace one equal thing with another. Okay, that's what the substitution property says. Symmetric property is an interesting one. So the symmetric property says if A equals B, then B equals A, right? So you think about the word symmetric, right? Within that is the word symmetry, and symmetry is kind of when something is the same on one side as it is the other. And so that's what's happening with these equations too. And this is the one that's like if you have 5 equals 2x minus 1, right? The symmetric property is what allows us to kind of flip that around and say, okay, if these two things are equal to each other, it doesn't matter what side they're on, we can change that to say 2x minus 1 equals 5. Okay, so symmetric property says you can change the order, or you can flip around what side something's on. As long as they're equal, you can do that. Okay. Now, these are the ones, when we think of algebra and when we solve equations, these are the ones that we use most often. Okay. And I had fill in the blank ones here. If you were in my class, I'd have you do these fill in the blank notes. But addition and subtraction property of equality says if you subtract or add something to one side of the equation, you must do the same to the other side. You must do the same to the other side. That means that, right, if you add something to one side, you got to add the same thing to the other side, right? So if I have 2x minus 1 equals 11, and if I plus 1 to cancel this here, I'm making a video. Hi, sorry. So if I plus 1 to both sides, right, or if I add 1 here, I also have to add 1 to the other side, right? And that's what we said with equations, to keep things in balance, okay? So I'll get 2x equals 12, right? And then my other one here, and it's going to be the same thing. Okay, so I did my fancy thing and copy and pasted that down. But yeah, if you multiply and divide something to one side of the equation, you have to do the same thing to the other side as well. So like in my same example, 2x is equal to 12. If I divide by this 2 to cancel it, again, to keep my equation in balance and keep it as an equation, I have to do the same thing to the other side, okay? So that's what the property of equality, addition and subtraction, multiplication and division. Technically, there are 4 different ones here, but I just grouped them into 2 and 2 just because makes it shorter. But yeah, you guys know that, but that's just putting a name to it. That's the addition property of equality, subtraction property of equality. Whatever operation you're doing to both sides, the property of equality makes that possible. So that's the most important that we use, that we have when we solve equations, okay? So I am going to do another video, like I said, of actually how does this apply to the problems that we've done, And then that'll be it. So thanks.